Well, let me start by just saying that Alex is certainly one of the fathers of molecular astrophysics. But the subject from the very beginning has been profoundly empirical, defying theoretical predictions. Before the discovery of interstellar CO, for example, we didn't know that whether 1% of the interstellar gas or 99% was H2. And the existence of molecular clouds, those great engines of star formation, roughly one-half the interstellar mass in a galaxy like ours, was completely unknown. They are the subject today of much of molecular astrophysics and the closely related study of star formation as well. So in fact, there have been many fathers of molecular astrophysics. Two should be cited along with Alex, are Hertzberg and Towns. The discovery of CH+ by Hertzberg and Douglas in 1940 is a minor masterpiece and has been mentioned in this meeting already. It still defies theoretical understanding after all these years. It is the first non-terrestrial molecule identified in space before being found in the laboratory, and the first of many. His influence, Hertzberg's, in astrophysics is vast, and even his very rare mistakes are edifying. His statement at the end of Diatomic Molecules, his great monograph, that the 3 Kelvin excitation of CN, which we now know to be the first measurement of the cosmic microwave background, was an entirely reasonable conclusion at the time. There are at least 2 branches of the Towns tree at this meeting, too. Jim Moran is one, I am another. The discovery of OH and interstellar masers was the direct outgrowth of work in Towns's lab at Columbia in the 1950s, and very early on he made a prophetic list of the molecules which might be detected in the interstellar gas. Our knowledge of the distribution of molecular clouds in the galaxy can be traced to Towns's laboratory and his students. But as this meeting shows, Alex's influence and contributions are omnipresent in molecular astrophysics. After Klemperer and the observers made us understand that ion molecule reactions and positive molecular ions were a necessary component of the interstellar gas, there was a widespread belief that negative ions were too fragile to be found, and partly for this reason, the necessary laboratory backup was not forthcoming. Well, we have now observed at least 5 polyatomic negative ions, have good laboratory data on even more, and more discoveries will certainly be made fairly soon. But from the very beginning, I was influenced by 2 of Alex's papers on negative ions, one very early on with Dick McCrae, that's right, with Dick, and one somewhat later with Steve Lepp. And what Alex and Lepp showed was that the ionization balance would shift from positive to neutrals and negative ions under certain conditions. So the idea that there were no negative ions in space. Yeah. Okay, so the idea that negative ions.
I think this will pick up better, okay. Or speak right into here.
Okay. So the idea that negative ions in space couldn't be found was simply a prejudice. And we have now, in the last 2 years, found a series of negative ions and found them in the laboratory as well. So it looks like the whole bestiary of negative ions will, in some sense, imitate those of positive ions. We already have a significant number to compare with the 14 to 15 positive ions that are known. And beyond that, I must say that Alex's general insight and his good judgment about all of these questions are really quite remarkable. He's always he never says something that is trivial or cannot be relied upon. He's one of the soundest speakers that I know in the scientific community. If he doesn't have something sensible to say, he doesn't say anything. So with this brief introduction, let me turn the meeting over now to an overview talk by Tom Hartquist, how interstellar chemistry and astrochemistry more generally became useful. Tom?